All right, so again, this 1.8a is quadratic inequalities. So quadratic meaning x squared, inequalities being greater than, less than, greater than or equal to, less than or equal to. So when you're solving these, your goal is to get whatever is on, whatever has an x, whatever an x squared, whatever it is, on one side so that a 0 is on the side by itself. And then you'll solve these as though it was just equal to 0. You'll usually get 2 answers from that. You'll plot those 2 answers on your number line, and then we do something called testing points. So let's just say I ended up moving everything, I ended up factoring it, and I ended up that x equals -1 and +1. I'd plot -1, I'd plot +1. And then to test points, we would have to plug values in, and we would plug them either in from in between or on the outside because the pattern goes every other. There are exceptions to that, but the pattern for the most part goes every other. So usually I look for something like 0. If 0 is in between those 2 numbers, I would take 0 and plug it back into the original inequality and see if it works. If it's true, then I know to shade in between. And if it's not true, then I know to shade on the outside. So if when I plug in 0, it works, I shade in between. If I plug in 0 and it doesn't work, I'd know to point them out like those oars on the boat. Yeah. Yeah, any number in between. So like even like let's say you end up with like -1 and 0. I would do -1 and 0. I would not want to plug in a fraction in between. I would this time plug in something on the outside. Like grab like the number 1, something that's easy, plug that in. And if it works, now I know it's on the outside. Does that make sense? Yeah. So that's what it means by testing points. We're going to plug those values back in. All right, so again, instructions say solve and write your answer in interval notation. So remember that you're going to give me interval notation on your test. You want to make sure you definitely understand it. So the first step is to get 0 on one side, and this is already done for you. So now I'm going to take the other side. You're going to take what's there, and then you're going to solve it however you can. So this could be factoring, this could be quadratic, this could be, well, I wouldn't recommend complete square, but it could be. You just have to move the 0 back again. But in this case, this is factorable. So I'm looking for the factors of -3 that sum to -2, which are -3, +1. And then I pretend that that's an equal. So I split and solve these, and I get x equals 3 and x equals -1. And then I draw my number line. And I plot those 2. -1 is smaller, so I do -1 and then 3. And then I want to plug in a value that's in between or on the outside of these. 0 is the easiest to plug in if you have that option. So I'm going to plug in that 0. And by plug it in, I mean go back to the beginning and plug it in. So I'd get 0 squared minus 2 times 0 minus 3 is less than 0. 0 squared is 0. -2 times 0 is 0. So this is -3 is less than 0. Is that a true statement? Yes. So I know I need these points included in my answers. So in between the points would get included. If it was false, I'd go outside. And do I put a parentheses or a bracket on those points? A parentheses because this is not or equal to. So my parentheses point in. I'd get from -1 to 3, and my interval notation would be -1 to 3 with a parentheses on either side. Rodrigo.
On the test, if we had to like draw the graph, would we do like -1? Like would we have, can we do it like that? Or would we have to put like 0, 1, 1, 2, 2?
No. You could put the minimum amount of points in there. Yeah, as long as you know what's there and you put it in the right order, you don't need to put all the other stuff. Yeah.
How do you know when to use like the filled in dots or circle dots versus parentheses or brackets?
You will now switch all the time to parentheses and brackets. Always. Yeah, we officially switch. Like when you get to Algebra 2 honors, now you switch. Pre-calc, you're going to keep brackets. Like anything beyond now, we're going to keep brackets and parentheses because of the interval notation.
Okay, so you just never use dots.
The only time you use a dot is if it's just one answer. Like the one we did yesterday where it was just 1/2. Like if 1/2's the only answer, then I get a dot. Yep.
Okay.
Valeska.
So you can use a function between or outside?
Correct. And if it's right, you shade that area. And if it's wrong, you shade the other part. Yep. All right, go to 2. It's already equal to 0 again, so I'm just going to factor. Factors of -6 that sum to -1. Good. -3, +2. Split and solve to get my 2 answers. Go to my number line. -2, 3. 0's in between again, so I'm going to use that one. 0 squared minus 0 minus 6 is less than 0. -6 is less than 0. True statement? Yep. So I shade in between again. And again, they get parentheses. -2 to 3 with a parentheses on both. Still with me? Yeah? Good. All right. Go to 3. Again, the 0's already there. So I factor. Factors of -20 that sum to -1. -5, +4, split and solve. X is 5. X is -4. Go to my number line. -4, +5. God bless you. 0 is in between again. So I plug in the 0. 0 squared minus 0 minus 20 is greater than or equal to 0. And I get -20 is greater than or equal to 0. Is that a true statement? No. So this time I cancel out. I don't use the space in between, and I use the space on the outside. Bracket or parentheses? Bracket because of the or equal to. So my interval notation, when they point out, goes -infinity to -4. This time it gets a bracket on the -4. Put a u in between. 5 to +infinity. Rodrigo.
On the test, if we ever had if we ever did the inside and it doesn't work, we know 100% and we don't have to do.
There are exceptions, like if you get a repeated answer, then you've got to plug in more. If you get 3 answers, you might have to plug in more if one of them's repeated. But for these, that's good enough. Like just the one. Yeah, Valeska.
Why did you do 2 separate?
Because the arrows point out, and it's or, which means it could be the left or it could be the right. Yeah. Yep. You just. All right, now go to 4. What's different with 4? There's a number on the front this time. So how do I factor these? First and last or trial and error. So if I do first times last, I get 4 times -6, which is -24. Factors of -24 that sum to -5. -8, +3. Replace my middle term with them. And factor by grouping. Take out a 4x, x minus 2, take out a +3, x minus 2. And I get x minus 2 and 4x plus 3. And then we split and solve. 2 and -3/4. Now 0 is still in between those, so I can still use it. And I plug it in. 4 times 0 squared minus 5 times 0 minus 6 is greater than 0. Goes away, -6 is not greater than 0. So I don't use the middle. I use the outer edges. Parentheses or bracket. Parentheses because it's not or equal to here. And then my interval notation, -infinity to -3/4 with a parentheses, union 2 to +infinity. All right, then obviously variations of that stuff. So when we look at 5, what would you have to do first? Distribute the x. So I'm going to get x squared plus x is less than 12. And then I need a 0 on the other side, so I'm going to subtract the 12. And I get x squared plus x minus 12 is less than 0. And then I want to factor, factors of negative 12, that sum to positive 1, positive 4, negative 3, split and solve. X equals negative 4, x equals positive 3. Plot them on the number line. Zeros in the middle. God bless you. And now I have choices. I could plug the 0 into my original, or once it's moved so that 0's on that side. It's easier with the 0, okay? But you can also do it at the beginning. It's easier with the 0 because the first two terms are going to cancel. And I get negative 12 is less than 0, which is true or false? True. So I know to shade in between these numbers, and it's a parentheses because it's not or equal to. But again, you could have also plugged the 0 in here. So 0 times 0 plus 1 is less than 12. I get 0 is less than 12, which is still true. It's not necessarily going to be the same statement, but if one is true, the other one should be true as well. Rodrigo.
For the graph, we have to have the arrows on the sides.
I would say only if one of your arrows is, like if they're pointing out, I would expect to see arrows. If they're pointing in, it's fine without it. Yeah. All right, 6. So if that was an equals, I would square root both sides and be at plus and minus 4, okay? Because it's inequality and we've been doing it the other way, but you can still do it that way. But because we've been setting it equal to 0, I would train myself to do the same thing. So I'd get x squared minus 16 is greater than or equal to 0. And then factor it. So factors of negative 16, that sum to, square root of 16. My brain should turn on at some point. Positive 4, negative 4, and then split and solve. And I get negative 4 and positive 4. So I would have gotten the same thing by square rooting as long as you remember to do plus and minus. You can only choose between those if there's an x squared and a number. You can't do that. You can't choose between them if there's an x squared and an x. That one you'd have to get everything to one side. So number line again, negative 4, positive 4, 0's in the middle. 0 squared greater than or equal to 16. 0 greater than or equal to 16. True or false? False. So I don't use the middle. I use the outside, and it's an or equals, so I get a bracket. Negative infinity to negative 4 with a bracket. 4 to positive infinity. All right, last two. So for 7, you're going to start by doing what? Add the 1 to the left-hand side. And then you try to factor. Are there factors of 1 that sum to 4? Nope. So how do I have to solve this? Quadratic formula. Yay! A is 1. B is 4. C is 1. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 4 plus and minus the square root of 16 minus 4 over 2. Negative 4 plus and minus square root 12 over 2. 12 breaks down to 2 and 6, 2 and 3. The 2's go to the outside. I get negative 4 plus and minus 2 square root 3 over 2, which is negative 2 plus and minus square root 3. Now here's where it gets a little bit more complicated when you're dealing with ones that are like that you have to use your quadratic on, right? I know smaller for sure is negative 2 minus square root 3, and bigger is negative 2 plus square root 3. But how do I know where the 0 lies? It's not as obvious anymore, right? So So what you have to do with these is approximate what your root 3 is going to be. It doesn't have to be perfect, but approximate. Root 3 is in between what two perfect squares? God bless you. 1 and 4, which means it's in between the square root of 1, which is 1, and the square root of 4, which is 2. So we can totally approximate it. It is 1.7, but let's just say you did 1.5. It would totally be fine because it's still going to let you know which one of those is positive and which one's negative. Oh, I was going, it's okay. Okay, so a -2 minus a 1.7 would be a -3.7. A -2 plus a 1.7 would be a -0.3, right? And it wouldn't matter exactly what that point, whatever was. That is where you're going to find out where that 0 lies. The 0 would lie in which direction? To the right. I would not want to plug in something in between those. Like I could plug in like a -1, but if you're not 100% certain about your decimals and we're rounding it, it would be safer just to find the 0. So the 0 is on the right-hand side, so I go back to the beginning and I plug the 0 in. 0 squared plus 4 times 0 is greater than -1. 0 is greater than -1. True or false? True. So I know I'm going outside the two answers, parentheses or bracket. Parentheses. So I'd get -infinity, and now I use the exact value, which is -2 minus root 3. Union, the exact value on the other side, -2 plus square root 3 to positive infinity.
So what would you have done if the statement was false?
Then I would have shaded in between. So my interval notation would have been -2 root 3, or sorry, -2 minus root 3 to positive -2 plus root 3. So if it was in here, you're saying?
If the 0 isn't inside your 2 points and like the rules get reversed.
If the 0 was in between and you plugged in the 0 and it was true, you would shade in the middle. If the 0 was in between and it was false, you'd shade outside. Yeah. So the only time I would say you can't use a 0 is, let's say one of your test points is 0. Obviously, then you have to find something else to plug in. And I would make it as easy on yourself as possible. If 1 is an option, use a 1. Okay? But make it as easy as you can for stuff like that. If it's quadratic, you can usually find the 0 because quadratic very rarely results. It would never result in 0 as a test point. All right, last one. What's different with this one? There's 4 terms, and what's the highest exponent? To the third. So this is no longer quadratic, which means there could be 3 answers, and that changes my number line situation. I then will have 3 test points, and so I have to plug in, and it still will be alternating. It would still be every other spot, but you might have to plug in more than 1 point. So the first thing I'm going to do is move the 48. Then I'm going to factor by grouping. From the left-hand side, I can take out an x squared. From the right-hand side, I can take out what? What goes into both 32 and 48? 16. -16. So this becomes 2x minus 3. And then I take out the 2x minus 3, and you group together the x squared minus 16. Am I done factoring? No. Nope, because this is the difference of 2 squares, x plus 4 and x minus 4. So now when I split and solve, I get 3 answers. 3 halves, -4, and +4. So first comes -4, then comes 3 halves or 1 1/2, and then comes 4. So as long as an answer doesn't repeat, like if I had 2 -4s, it's going to mess up my pattern. As long as an answer doesn't repeat like this, then my pattern is every other spacing, which means it's either going to be here and here, or it's going to be here and here. I would still recommend plotting 2 points just to be sure, like testing 2 points, just if you have the time, just to be sure. But as long as my answers don't repeat, then that's the pattern. If your answers repeat, then you have to test more than 1 point for sure. Yeah. Like if you got x squared minus 2x plus 1, that's x minus 1 and x minus 1, so 1 will happen twice, like that. So I'm going to find 0. It's in between the -4 and the 1/2. I'm going to plug that in. So 2 times 0 to the third minus 3 times 0 to the second minus 32 times 0 is greater than -48. And all of these are 0. 0 is greater than 48, which means that part works. And I assume the part on the right works. If an answer repeated, I have to plug in more than one term. But because that's not happening here, I'm going to go with every other. These are going to get parentheses, and this is going to get a parentheses. Valeska. Yeah, so I would pick a point, obviously pick a point that's bigger. These are big numbers, but like if you pick 5, I would plug in 5. So 2, 5 to the third minus 3, 5 squared minus 32 times 5 is greater than -48. Oh. If it repeats, so you'd get like 2, you'd get like 1, but it would be twice. And you'd get like 2, let's say, you'd have to plug in more than one term. I'd have to plug in a spot from all of those. Yeah, if you got x equals 1 and there were 2 of them. Or x equals 2 and there are 2 of them. Or x equals 0 and there are 2 of them. That's when that pattern is not always going to be every other. So I would plug in points from each range. Yeah. So like an x squared equals 0 results in 2 zeros, right? Something like that. All right, so this interval notation is weird because it's got 2 parts to it. It's got the -4 to 3 and 3/2. And then how do we separate out two interval notations? The u, and it's 4 to positive infinity. So you'd need both. Sophia, you had a question? Oh,
Why would the 4 like branch out?
Because it's every other space, and if you weren't sure, and you take and you plug in like the 5 like that I started, this would be 2 times 125 minus 3 times 25 minus 160. So I'd get 250 minus 75 minus 160. If I combine these together, 250 minus 235 is 15, which is greater than -48. So that's how I can check to make sure that that section works too. So that one worked because we plugged in the 0, and the one on the right works because you're plugging in the 5. But the rule is if you get 3 answers and nothing repeats, it's still in every other section scenario. Correct. But it could be reversed. Like it could have been this side and then in between there. It just would skip that section in between. Yeah. And you'll know that by plugging in that 0. If that 0 didn't work, then I would know it'd be the other 2 sections. Does that make sense? Yeah, okay.
Why for the one before it worked, but like I don't know, it's like not in between?
Because 0 was on the right this time. 0 was not in between. 0 would not, right? Because we approximated -3.7 and -0.3, which means 0 would have been on the right. So wherever it works is the segment that the section that you're shading. If 0 was in between those two, then it would have been in between.
What if 0 was like before the negative? Well,
If it was in between here and we plugged it in at work, then I would shade in between.
no, well,
Oh.
I mean, if it was like before the -2, even though it wouldn't make sense, but like, what if it was there?
Then that's the area we would have shaded. You're saying what if it was here?
No, on the other side, but with these numbers, it doesn't make sense.
On the other side here?
Uh-huh.
Then I would have shaded outside still. Yeah, if it works on either of the outsides, I know to shade the outside. If it works on the inside, I shade the inside.
Okay.
Yep.
If it was 2 negative numbers, would you still use 0 or not?
I mean, I still pick 0, but I know that it's to the right. It's not in between anymore. Yeah, if 0 is an option, I always use 0. The only time you can't use 0 if 0 is one of your test points. That's it. Every other time I use 0 because it's way easier to plug 0 in than any other number. We're good? Yeah? All right, you've got a good amount of time to work on that 1.8 assignment if you want to get a head start.